going to use tool 1 in my first machining operation. What's our first machining operation typically?
Facing.
Facing. What does facing do for us? It establishes a Z datum. All right? And it is usually the first thing we do. So I came out of the insert screen, you rascal. So now I need to escape one more so I can get the bottom keys active. I need to come down and highlight operation 7 because I want to insert above it. So now I press F3 to insert. Now, I come across the bottom and look at my selections. This is where, I believe you guys might have done this last year, where you program rapids and linears and arcs. We are not going to do any of that. We are going to use can cycles. We do not need to position before and after can cycles. So we just got done using F4 to define our tool, and we've used other before. Here we're going to use cycles for can cycles, F5. When I press F5, the cycles that pop up are drilling, boring, tapping, face, the one we're going to use, rectangular pocket, circular pocket, frame, thread, cleanout. Okay, so keep it simple. We're going to choose F4 face. Blank program here. So, start position. There's something I need to call out to you here. In this conversational box, we have to the very far right, incremental, incremental, incremental. So I need you to pay attention where there is incremental and when there is not. If it does not say incremental, what is the default? Absolute. Absolute and incremental are two of the coordinate systems. If it's an absolute coordinate system, what is it going to be in reference to at this point in our program? Our WCS, which is G54. Because we put G54 at the top of our program. So get that into your head. These questions it's asking us now, which is part of the deal, is like, what is this thing asking me? And what is it going to do with this information? The start position in X and Y is absolute in reference to G54. Now, let me see if I can pull up my, whoops, wrong mouse, Damon.
So if you were starting at 0, 0 in X and Y, you'd be starting in the middle of your part.
Correct. So here in X and Y, we have decided to make this jaw, the best place to put the work coordinate system is in the middle of X and Y and down 0.1225 into our stock in Z. So I'm going to leave that right there, and we're going to go back to, matter of fact, I'm going to leave this up for a second. So in our Intercon software, it's asking for the start position in X. Now this question says, where do you want your cutter to start facing? In X only, in relationship to G54. And I need to give it a number. So, I'm going to lob a softball at you. My stock is 6.125 inches long. Half of that is 3.0625. So I need my tool to be left, because I want to start facing near this work stop over here and work across my part. So I want to go over here. Now, I need to travel half my part, 3.0625. I'm going to get my calculator up here because big fan of that. 3.0625. Now my tool right now, my positioning is in reference to the center of my tool for the start position. Center of the tool. So right now, if I just go half my part, I'm going to be right in the middle of my tool. I need to go farther to get my tool completely off my part. so I can plunge down to a cutting depth in Z. So on top of that 3.0625, which is half my part, I need to now add half my cutter, which is a half an inch. So I'm going to add plus 0.5. So right now my cutter is exactly at the edge of my part. Not a good idea. I don't want to plunge down in Z and possibly hit my part. So now I'm going to throw a little margin at it, okay, just to get off my part a little bit. My technique is I'm going to throw 50 thou at it, 0.05. So on here I'm going to add 0.005. This is the number that is going to go into X. Well, actually, it's not going to be positive because I want to go to the left. Negative 3.6125. So, where am I at? Negative 3.6125. Is that what I had?
Yes.
All right, we'll circle back to questions here and solidify this stuff in a sec. Now, Y. The coordinate Y, not the reason why. So I got X good. Now I need to know how much I want to engage the cutter axially in this cut. I'm going to make this easy on myself. In Y, I'm just going to put a positive 1 inch. And I'm going to have a 50% cutter engagement. As a general rule of thumb, we do not want to engage our cutters radially more than 2/3 of the cutter diameter because the cutter needs to deflect in a direction. So you never want 100% cutter engagement. So here, I'm going to go positive 1 inch in Y. So that is just a starting point in X and Y. Now for Z. Surface height. It doesn't even say Z. Every one of the toolpaths you write are going to have this surface height in there. And here's what it is asking you. Where is my cutter going to find stock? Where is my cutter going to engage stock? For this facing cut, it is going, and it's in relationship to G54 because it doesn't say incremental over to the side of it. So this is absolute. So my cutter is going to find stock at 0.1225 because I put positive. That's a positive number. My G54Z is into my stock 0.1225. So from there, it's going to find stock positive 0.1225. All right, incremental, yay! When it goes incremental, basically your life gets easier. Because right now you're trying to think from where you put the origin, you got this picture in your head, and you're trying to see all that stuff. Well, right now, these next call-outs is going to be from where you're at right now. So we are 50 thou off my part, negative X. How far do you want it to go in X to face this part?
50 thou off the other side.
Oh, man, awesome. 50 thou off the other side. You know what I really like about that? Man, we already did that work. Did we not? We did it right here on our calculator. We did all that math to get 50 thou off to our left side. So now we take this number, multiply it times 2. And that'll get us the same distance off the other side of the part. So, times 2.
Wait, but we're at half, and we went negative.
Correct.
So shouldn't it just be 3.6125?
No. No, it is incremental.
It's incremental.
It's incremental. Remember that's get that? That's key. All right, so 7.225. 7.225. And that is a positive number because I am going in a positive direction. All right. So here's another incremental. It wants to know how far it needs to face in Y. Incrementally. So right now the center of my cutter is on the far side of my stock. And I'm cutting 1/2 inch stock. So how much further do I want that cutter to go in Y? -2 inches. I'm using 2-inch stock. Basically, I'm defining the boundaries of its facing. -2. And then here's a depth. It knows from up here on surface height, it knows where it's going to find stock, and it needs to know how much of that you want to take off. In our case, we're going to take all of that off. 0.1225. You might decide that's too much for my cutter. I need to do it in multiple passes.
So that was the question we had. You can't designate it in.
You cannot designate multiple facing passes in this toolpath.
So you just have
I will show you how to do that. But we're going to keep our training wheels on just a little bit longer. Now, step increment. Step increment is how much you want this cutter to move over every cut. And what was the rule of thumb I just used a minute ago for 2/3? So here's how I do this, guys. I take my 1 inch and I multiply it, or I'm sorry, back up, and I divide it by 3. Okay, 0.333, that is 1/3. Okay, then I can take that 1/3. Notice I can do math in these boxes. Isn't that cool? I'm going to take this dude and multiply it times 2. So there's 2/3. Anybody else have a way that they like to do that to get to 2/3 really easy? You got a way of doing that? Times 0.66, because, well, you knew that was...
Yeah, but that's the same.
It is the same thing, exactly.
30% of 1.
So we might have different ways of getting to the same thing. I'm explaining how my brain gets the thing, so if you find something, share it with me. Totally open to learning new ways. Feed rate. All right, boys, feed rate. Get your pencils sharp. I'm gonna lay some stuff down on you. First thing I do is I get my calculator out.
I got it, Chef. I got it. 2 seconds.
All right, we'll circle back around with this. Gets back with a sharpened pencil. But the equation for feed rate is RPM times chip load times number of flutes. RPM times chip load times number of flutes. So let me take all of the mystique out of that scary new formula. RPM you already know how to do. We came up, I put 1100 for my RPM because I didn't want to mess with the 1146. So I know the RPM. Yay. How many flutes are on my cutter? 4. Dude, I'm already there. 1100 times 4. Just gonna hit enter and hold that there. So there's 2 of the parts of my equation. So, and those are given. This is the only variable that you need to concern yourself with, and that is chip load. What is chip load? Chip load is how much of a bite or how much of a chip you want every cutting edge to take. And if you took your chip and measured it with your micrometer and it measured 10 thou thick, then that would be a 10 thou chip load. So we control feed rate by adjusting chip load. In our case, we are going to go with a 5,000th chip load. So I'm going to multiply 4,400 times 0.005. And it gives me 22. Right here for feed rate, I give it 22.
So question on that, on chip load, would you, if you had a tooling, would that information be on the box?
Okay, chip load. So the question is, where do I get chip load from? I am going to feed you chip load early on. Okay, for my classes, I'm going to provide, matter of fact, like this 5 thou, I'm just going to throw that one at you and give that to you. In Pro Shop, when you pull up tool RTA3, it's going to tell you which insert is on that tool. And when you go to that insert page, I have data there linked that tells you what the manufacturer says you can use for an SFM multiplier and chip load. Now here's where you're going to have to take all of that information with a grain of salt. The manufacturer will give you a range, and that might work for you. On these machines, we're using bed mills that have seen a better day. We've got some runouts in the axes. We've got some bearings maybe in the spindle. The rigidity of my work holding, the rigidity of my cutter, I might not be able to cut at manufacturer's recommendations. A program is only good until you hit cycle start. And then the setup machinist is typically going to need to adjust his program. All right, feed rate, 22. Notice when I hit 22 that I got an M. Any idea what the M is? Modal. This feed rate is going to be modal. I believe, what is modal? Modal means it is active until canceled. In this case, a 22 inches per minute feed rate would be active until another feed rate came out. All right, I went back up to that line, and notice F1 says modal or fixed. Oh man, I clicked it 3 times and it did away with it. Let me put that back. I'm just going to leave it modal, but you can change that. Plunge rate. Plunge rate is another, I think it's a weird thing, just like surface height is here. Surface height looks very vague. It doesn't tell you which axis it is, and plunge rate is very vague and it doesn't give you an axis. And both of those vague lines are talking about the same thing. They're talking about Z. Surface height was talking about when it's going to find, when's my cutter going to find stock. And plunge is going to program at what feed rate my cutter is going to feed in Z to get down to the cut depth. Intercon has a default feed plane of 100 thou above your stock. That's why it asked me where surface height is. I'm going to be in a G00 until my cutter gets to 100 thou above my stock. At that point, it's going to change over to feed, and it needs to know a feed rate at that point. Okay? And here is another rule of thumb for me. Are we going to be cutting when we plunge to our cut depth at the beginning of this toolpath? The answer is no. We're going to be plunging in the air. So I don't need to calculate feed rates for cutting. So what I do is I use a generic feed rate that allows me, the operator, to catch a mistake. I don't want to put 100 here. All right. I typically put 25 inches. 2.5. So that is my go-to for a non-cutting plunge. It gives me time to catch it. Okay, now it is time to accept this toolpath. F10. Now I need to check my work. How I'm going to check my work is I need to graph this toolpath. So I need to escape once. Now F8 graph is available. So I clicked F8 graph, and here is what it gave me. First thing I want to point out is red is rapid, yellow is feed. Doesn't do me a whole lot of good here. And this thing went so fast. So what I'm going to do really quick to allow you to see this toolpath is I'm going to take the feed rate override and I'm going to turn that dude to the left. Now, it's not turned off, I'm on about a third. And I'm going to hit redraw. So now I can watch this thing cut. Okay. This graphing is part of our crash mitigation. We're going to kind of take a look at it right now. And the reason I call that out is because I need to look at it and I need to glean information from it. I'm not just going, ooh, yeah, that looks about right. It's starting left and ending there. What I want to do is, where is my WCS? So I just hit a cursor, keyboard cursor, and it brought up these crosshairs, and it defaulted at X0 and Y0. So right there in the center is where I put the WCS on my part. So it looks like I'm starting 3.0, oh, what the heck was it, 3.7 something to the left. It's going the full distance of my part, taking that pass. It looks good in X and Y. Now for Z, I need to hit F2 for view. And up in the right-hand corner, by hitting view once, it went to the right view. I'm going to hit view again, F2, and here's the front view. Okay, so here's what I'm looking for in front or right view. I want to know what my Z depth for this cut is. Where does it look like it cut to?
The center of the part.
In Z specifically.
Top of your stock.
Based off that,
No.
All right, let me zoom in here. Okay, so this right here is Z0.
So it's slightly.
So my facing toolpath faced off 0.1225 of stock and faced down to Z0. I faced down to Z0. So that is what is unique about this toolpath.